I was talking yesterday about the fact that your green book is all you need to study from for your final. But some of you still say, I want more work. Whatever. So, go to my page. Search Review Links. This is being recorded, so you don't even need to memorize it. Review Links, grade 10. When you click on that, up will come a little video talking about it, and in the in the description, you will see that there is a 3 or 5 links. All of you, and that's what's being described in the video right now, all of you will want this one. The trig and the rads are for my honors classes. You don't need those. And there are 2 practice tests you can try. I can't remember if the tests have a key or not. All right? So if you want more review stuff, that's how you find it. All right? And I'm 90% sure almost all of this has review or has answers. Okay? Okay. Any questiones from page, whatever page this is? Page 239. There shouldn't be, because page 239 is what you just did a test on, and 99% of the class passed it. So nobody should have any questions about this, because it's just graphing 2 lines and telling me where they meet. No? Number 9, I heard someone say. Well, there's the 2 lines, right? So you'd have to put them on a graph and find out when they cross. The only hard thing about putting them on a graph is fitting them on a graph, yes? So if you were to put them on a graph, I would go S down here, P up here, and I would make these hundreds. So 100, 200, 300, 400, and so on. So you would have a dot at 700 and a dot at 1,000, right? And then these, I would simply go out. Actually, what I would do, looking at it in a second time, I would get rid of these altogether, right? By multiplying that by 100. So I would have 70,000 equals 3, plus 3s and 1, 2, 3, 4, 5, and 100,000 plus 2s. That's what I'd do. And then I would make each of these 1,000. So I was up at 7,000 or 70,000. I would make each of these 10,000, and that would be 10. And then I would do the graph from there. And I would go out that way. But that's all you're doing, right? It's only a bigger graph. There's nothing tricky about it. It's exactly the same thing. Okay? Whoever asked about number 9. Anything else? Okay, let us move on then, cabbages. Everybody turn to page 240. Now listen to me. There are 2 algebraic ways to solve systems. They are both equally effective, but they cannot be taught at the same time. Every year back when I first started teaching, I would teach one of them first and the other one second. And every year, the kids would all say, oh my God, the second way is so much easier. Why didn't you teach it that way first? So what did I do next year? Switched them. And then what did the kids do? Every single one of them. Oh my God, the second way was so much easier. Why don't you switch them? So I would switch them again. And then what would the kids do? Same thing every time. And it got frustrating to me. So now I don't care. I start with this one, and then I teach the other one. And everybody can just screw off. Okay? Okay. We're going to do this one first, though. The list of steps is right there. Please read it right now to yourself and tell me if there is any part of that that makes no sense. Are there any words in that are confusing? Remember, we haven't tried it yet. For those of you in grade 9, you haven't tried it yet. For those of you who were in grade 10, you've probably seen this before. Does everybody understand all these words? Again, I am saying you do not need to know how to do it yet. You just need to understand all the words. Yes? Okay, let's try it now. Step 1, I'm going to do in black. Choose an equation and solve for one variable. Solve means isolate one variable. And then I even give you a hint. If there is one, choose a letter with a coefficient of 1 or negative 1. Do I have that anywhere in my first system? Anywhere. Yes, I do. I have an x equals 1 right there. So step 1, I have chosen my equation, but I have not solved for x yet, have I? To solve for x, I need to isolate x, which means what has to move? What has to move from here to isolate x? Negative 4y. When negative 4y moves, what does it become? X equals 4y minus 1. Is everybody cool? That is step 1. It's all done in black, so it's nicely color-coded. Step 2, which is circled in red, which means I'm going to do the work in red. Gentlemen, shut up. Stop playing footsies. It's cute, but you don't need to. Okay? If you don't want to do math, just sit quietly and don't make a sound. Okay? It's the simplest instruction I can possibly give. Just sit and breathe. Okay? I don't want to have to fail you on breathing, since I'm already probably failing you on math. Got it? Okay. This is the new equation, because as you can see, that equation was never written over here, was it? Was it? So that's a new equation. Now it says substitute it into the other equation. X equals 4y minus 1. What letter do you see right there? X. What is x? 4y minus 1. So step 2, 3, not x, 4y minus 1 plus 5y equals 31. Does everybody understand that step? Because x equals that, and there is an x, I am allowed to write 4y minus 1. We have been doing this in the past a lot, haven't we? So this is not a new step to anyone. That's why this is the last unit. It takes stuff from every other unit. That's step 2 in red. Step 3 in blue. Solve for the remaining variable. Remember, solving means isolating the last variable. Now, when I'm doing these examples, it's always going to be x and y. But will it in real life? No, because maybe I'm comparing distance and time. Okay? So now, solve it. So now I got to isolate y. What do I have to do to isolate y? I have to do algebra. What do I do here? Distribute. What do I get? 12y minus 3 plus 5y equals 31. What do I do with 12 and 5? Add them. 17y minus 3 equals 31. What do I do with the minus 3? Move it over here and it becomes plus 3. 17y equals 34. Now what? Divide by 17. Y equals 2. Everybody cool? Now, I'm going to circle in green because that's the fourth step. Y equals 2. Now I know what y is. Do I know what x is? No, because I have to bring that to there. What do I write instead of y? 4 times 2 minus 1. What is 4 times 2? 8 minus 1, 7. X equals 7. That's step 4. Lastly, what is my answer? 7, 2, because x's go first. And of course, none of you are going to check, but you should. Is 7, 4 times 2 is 8. Is 7 minus 8 negative 1? Yep. 3 times 7 is 21. 5 times 2 is 10. Is 21 plus 10 31? Yes, so I've done it correctly. Does everyone understand? Good. Now you try it. Step 1 we do in black. Which equation am I going to choose to work with, and why am I choosing to work with that one? See what I did there? See what I did? That's okay, Jimmy. Which equation am I going to work with? Top one. Why, Zach? Because y has a coefficient of 1. So this becomes y equals 3 minus 2x. Everybody cool? Everybody cool? Now, what do? I take that answer, my new equation, and I take the y of it, and where do I put it? Damn it, I left part of the x. I'm just going to move it. I can't move it. Everything's screwed. Oh my God. Ah! Ah! One time, while my computer is being a pain in the ass, one time I gave my kids, my students, a test, and I said, one of the questions was, how would you do this? And then in the instructions I said, this means you have to pretend that you're the teacher and you have to teach me how to do this question. So the kid starts writing and he starts drawing stuff. And then he draws arrows and things. And then he draws things like, then he wrote, my computer froze. My computer. Arrgh. And he put it all in the work because that was me. I gave him full marks. And he did it right. I mean, that's, 3. It's supposed to be black. Screw it. Minus 2x. Now that goes in down here. 4x plus 3, but not y. What is it really? 3 minus 2x equals 1. Ooh! And then, of course, we solve. 4x plus 9 minus 6x equals 1. Negative 2x plus 9 equals 1. Negative 2x equals negative 8. X equals 4. What do I do with x? Goes back in up there. Y equals 3 minus 2 times 4. 3 minus 8, negative 5. What is my answer? 4, negative 5. And I check it. Is 2 times 4 is what? 8 plus negative 5. Is that 3? Yeah, sure, you betcha. What's 4 times 4? 16. What's 3 times negative 5? Negative 15. Is 16 minus 15 1? Yeah, sure, you betcha. So did we do it right? Yes. Now, turn the page over and observe. Look at that and tell me why it makes you angry. There's no coefficient of 1. But what do you see there? 2 4x's. So what if I did this? 4x equals 2 minus 5y. Is everyone cool with that? Everyone cool with what I did? Now, if 4x equals that, can I put that in for 4x? Yeah, sure, you betcha. Because 4x is that. So I can write 2 minus 5y minus 20y equals negative 3. 2 minus 25y equals negative 3. Minus 25y equals negative 5. Y equals 1/5. Uh-oh, fractions. That makes us tremble and cry, doesn't it? Does it need to? No. Y equals 1/5, so it comes back up there. Right? 4x equals 2 minus 5 times what? 1/5. Correct? 4x equals... What happens to those two 5s? They cancel. So it's 2 minus 1. 4x equals 1. Right? X equals 1/4. What is my ordered pair? 1/4, 1/5. And then I check. What's 4 times 1/4? 1. What's 5 times 1/5? 1. Is 1 plus 1 2? Yeah, sure, you betcha. 4 times 1/4 is 1. 20 times 1/5 is 4. Is 1 minus 4 negative 3? Yeah, sure, you betcha. Is everybody good? It's not hard, is it? And yet, when I show you the other one, even though the other one is actually way harder to explain, you're all going to still say, I like it better. But you're not, because now I've said that you're all going to say that. So just to be contrary, you're all going to say, no, I'm glad you did substitution first. That's okay. I'm used to that too. Everybody good? All right. It's 12:35. I am wondering how... oh, no, because we want to go over the test. So I'm going to give you now... page 242 and 243 are your work. Remember, 243 is really only good for a joke. If you can do all of 242 and you get all the right answers, then doing 243 you don't really need to do because it's just more substitution practice. But the joke's pretty funny, that one. That's actually a funny one. Or, of course, you could just do page 243 if you want. I don't really care. But I'm going to let you work for 15 minutes, which takes us to 12:50. At 12:50, I'm going to do the next lesson, and then I need to do 2 lessons tomorrow and a review and your test. Elimination. So you got 15 minutes now. Go diddly oh. I cut this a little bit short in this section because of time. I am not going to go into why this works. I'm going to pick some highlights out of it. Excuse me. Step 1, I want you to solve this by graphing. It will take literally 2 seconds. 3y equals negative 4x. Y equals negative 4/3 x. Negative 3y equals negative 5x plus 27. Y equals 5/3 x minus 9. Come over here. Make my graph. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3. The other one is down 1 from 0. 1, 2, 1, 2, 3. And there is where they cross. Which means the solution is 3, negative 4. Right? Everyone agree? Okay. I know most of you didn't graph it, but that's okay because this is kind of review. This part is important. Everybody pick a number. Everybody pick a number and multiply this equation by that number. You choose your number, then multiply the equation. Whatever you choose. I'm going to wait a second. I'm going to do mine. I'm going to choose my number at random and then follow the instructions. So, multiply both sides, then solve for y. It should already be done. And what do you notice? You get the exact same answer. And you already know that from previous math because 1/3 times 4 times 4 is 4/12. The exact same amount. What does this tell us? This tells us that if I multiply a linear equation, both sides of it, it results in the same equation, but with new numbers. Does everybody understand? The shortcut for this is it changes the looks. It's like a disguise. Dum, dum, dum. And just like Scooby-Doo, we are going to pull the mask off, and then the equation will be mad at us and call us meddling kids. All right? That is step 1. Turn the page over. We are just going to do the first thing here. What would happen if we added these equations? What is 4x and 5x? 9x. What is 3 plus negative 3? 0y. It disappears. 9x equals 27. What happened? one variable disappeared. We aren't going to do the graphing. We aren't going to do the subtraction. But we are going to do this one. Adding or subtracting two linear equations results in, or wait, I'm not going to say results in because we skipped a bunch of stuff. I'm going to change this to say can result in a third equation that has only one variable. Everybody cool? Now we've skipped a bunch of stuff to get to here. Now, knowing what you know, what could I do to either one of these equations to write another equation that would still work? What was the very first thing we did? Multiply. So I could multiply either of these equations by any number. Well, you wouldn't use 1 because then it would be the same equation. I could multiply either of these by any equation and I would get a third equation that would work. So if I multiplied that by 2, what would I get? Plus 4y equals 36. Right? Everybody cool? If I can multiply, does that mean I can divide and have it work? Right. Multiplying works, so dividing works. Is everybody good to there? That takes like half an hour to get to there if you actually learn why it works. Does everybody trust me? The short version is the 1/2 times 3 times 3, 3/6. If you understand that, you understand this. Do you? Sweet. Turn the page over. And now this is the second method. Again, I am going to use colors. The first thing I'm going to use is red. Add or subtract the equations to get rid of one variable. Notice I haven't typed any hints here. I'm going to give you the hint now. Hint. Look for the common coefficient. That's step 1. Step 2. Solve for the remaining variable, which means we isolate. Step 3. Plug in to find the remaining variable. That is the same as substitution. So let's do this. Step 1. Is there a variable there that has the same coefficient? Which one? Y. Now, if I'm going, it says add or subtract. What will make this 5 disappear? Adding. So I'm going to add. What is 3 plus 4? 7x. The y's disappear. What is negative 9 plus 23? 14. That is step 1. Step 2, isolate the remaining variable. What do I do? Divide by 7. What does x equal? 2. Now x equals 2. If x equals 2, what can I write in either that one or that one? 2. Does it matter with which I choose to work? No. If I work with the top one, it would be 3 times 2 minus 5y equals negative 9, which would be 6 minus 5y equals negative 9, which would be negative 5y equals negative 15. Y would equal 3. Right? Or, and I'll change shades of green, I could have done 4 times 2 minus 5y equals 23. 4 times 2, plus 5y. 4 times 2 is 8, plus 5y equals 23. 5y equals 15, y equals 3. They both work. And what is my final answer? The pair, 2, 3. What is my last job? Check it. How many times do I need to check it? Only once, because I got 2 and 3 from one of these equations, didn't I? So I only got to check the other one. If I did the dark green one, I take 2 and 3 and I put them in here. 4 times 2 is 8. 5 times 3 is 15. 8 plus 15 is 23, and I know I'm right. Ease, bees, lemon squeezy, right? Now, this is when everybody says this one's way better. Why did we learn it first? Now, look at the next question. Sometimes you will need to multiply them in order to get elimination to work. When do we have to multiply them? If there's no common coefficient. So, let's look at that first one. Is there a common coefficient? No. 1, 3, 2, 4. They don't work. So I got to do some multiplying. If I multiply by 3, will I be able to eliminate something? Yes. If I multiply by 2, will I be able to eliminate something? Yes. Who makes the decision? You do. Which one do you guys want to multiply by? You want to multiply by 3? Okay. If I multiply by 3, I'm going to rewrite it down here. What does this become? No, we're multiplying just the top one. 3x minus 6y equals 21. Now, that's step 1, kind of, because the rest of step 1 is to get rid of a variable. How will I get rid of the x? Is it going to be adding or subtracting? Subtracting. 3 minus 3 is gone. 4 minus 6 is what? 10y. 1 minus 21 is what? Negative 20. Now I solve for y. What do I do? Divide by 10 and y equals what? What? Negative 2. Where can I put that negative 2? Anywhere I see a y. It doesn't matter which one I use. Which one do you want to use? The top one? Okay. X minus 2 times minus 2 equals 7. X plus 4 equals 7. X equals 3. What is my ordered pair? 3, negative 2. Now, I worked with the top one, right? So I know the top one is correct. So I'm going to check the bottom one. What's 3 times 3? 9. What's 4 times negative 2? Is 9 plus negative 8, 1. So we're correct. Is everybody good? All right, let's look at the next one. Are there any common coefficients? No. So I got to make a common coefficient, don't I? When have we had two numbers that we've changed in order to make them the same? That's lowest common multiple, isn't it? Which we did in Unit 3. I could do the lowest common multiple of 11 and 2, or the lowest common multiple of 3 and 2. Which one do you want to do? 3 and 2. What is the lowest common multiple of 3 and 2? 6. So I need to make these y's 6. What will make the top one 6? Multiplying it by 2, which gets me 4x minus 6y equals 40. Right? What will make the bottom one 6? Multiplying by 3. 33x plus 6y equals negative 3. Now, what eliminates? Adding or subtracting? Adding. 4 plus 33, 37x. That disappears. 40 plus negative 3 is 37. What does x equal? X equals 1. Where can I put that 1? Anywhere I see an x. 11 times 1 plus 2y equals negative 1. 11 plus 2y equals negative 1. 2y equals negative 12. Y equals negative 6. What's my ordered pair? 1, 6. I know the bottom one works because that's the one I just did. What should I check it with? Top one. What's 2 times 1? 2. What's 3? Forgot the negative. What's negative 3 times negative 6? Positive 18. Is 2 plus 18 20? Yeah, sure, you betcha. Now, I'm glad I forgot to bring that negative because when I did this, I saw it didn't work, did it? Even though I was positive I was right down here. So then I went back and looked. Negative 6. Oh, I didn't have the negative. What a dunderhead. I better put the negative in, and then it worked. Everybody good? Lovely. And it is 1:05. Your homework tonight is to attempt either page 247 or this puzzle sheet. This one on, if world peace is a 10, this is about an 8. Okay? Okay. I am done